What's up, nerds? Happy studying. Are you as sleep deprived as I am? If not, then you're not trying hard enough. Let's get into some calculus. So today we're going to be learning about something called a partial derivative. But Sakio, I hear you ask, I know what a derivative is, but what is this partial shit? Let me explain. So when you were in Cal 1 and 2, you were working in two dimensions, so your functions look a little something like this, f of x equals x squared, something along those lines. Because you were working in two dimensions, most of your functions only required one variable to correspond with values along one axis, and the values along another axis were determined by the output of a function of that variable. Now that we're in Cal C, and we're working in three dimensions, oftentimes our functions are going to make use of two variables. Let's say, for example, this function, which has inputs of x and y, returns value of x squared y cubed. So how do we derive a function like this? You fucking can't. But what you can do is derive it partially in terms of one of its variables. So the operation notation for that looks like del f over del x. Now the symbol del is a Greek symbol. It's slightly different from d, and that's to signify that it's a partial derivative instead of a total derivative. So if we want to partially derive the function x squared times y cubed in terms of x, what we need to do is isolate any part of the expression that directly relies on x. In this case, it would be x squared. Any other part of the expression, like things that depend on y, are treated as constants, like e or 3 or pi. They're all the same thing, right? So now that we've isolated the relevant variable, what we can do is move all our constants outside the derivation. So this becomes y cubed del x squared. And that's the same thing as y cubed dx x squared. In which case we can just perform the derivation and then multiply later. That gets us y cubed times 2x. Let's use another example. Let's say f of xy equals cosine xy. But how do we find the x partial of that? Well, we know that cosine derived is negative sine, so we use that operator with the same input parameters. And because of chain rule, we multiply that by the x partial of what was in cosine. And the x partial for xy is equal to y times derivative of x. We know that d dx of x is 1, so that turns into y. So the x partial of our function becomes y times negative sine xy. If we were to derive partially in terms of y, we'd see that it's the exact same thing, but we isolate y instead of x. Thank you guys so much for your time. I hope you learned a lot. All our brains just got a little bit bigger. Next lesson is going to combine some stuff from the first two, because we're going to be going over the gradient operator. It's a vector.